All right, here we go with square roots. Okay, let me write a couple of them right here. We have some square roots right here that can be simplified very quickly, very easily, and one that cannot. So let's start with the first one. The first one is the square root of 25. The square root of 25 is 5. And the reason why it's 5, because you can square a 5 to get 25. And of course, the squared means 5 times 5. Okay, so if you can square a number to get the number that's inside the square root, then you can simplify it like so. So here we have the square root of 36. The square root of 36 is 6. And now we have the square root of 50. Now 50 is not a perfect square. So we need to talk about what you can do with square roots. You can multiply them. So if you had something like square root of 2 times the square root of 3, that would equal the square root of 6. Because we could do things like this with square roots, we could also go backwards. We can split up square root of 6 into these two things. So we can split up the square root of 50, like square root of 25 times 2, or the square root of 5 times 10. Now, I'm not going to use this one, and the reason why I'm not going to use that one is because neither 5 or 10 are perfect squares, and so I wouldn't be able to simplify those. But for this one right here, the square root of 25, we know, as stated above, you can simplify the square root of 25. So now we can write this as 5 times the square root of 2. 2 is not a perfect square, so he's going to stay inside the square root, and that's it. And you can do that with a lot of different square roots, like the square root of 10. You could split this one up into 2 and 5 or 1 and 10. But you know what? None of these has a perfect square. So if we don't have a perfect square in any of those, then that just happens to be your answer. You can't simplify it. It's unsimplifiable. Okay, so now let's talk about variables. Okay, so I wrote down some perfect square variables. And these are perfect squares. Well, I guess you'll find out why they're perfect squares. See, what we're trying to do is we're trying to take the square root of x to the 14. We're asking, what can we square to get x to the 14? Now, if you know your laws of exponents, you might say right away that x to the 7th squared will give you x to the 14. That means the square root of x to the 14 is going to be x to the 7th. And if we did x to the 8th, the square root of that, we would get x to the 4th. The square root of x squared, that would be x to the 1. And of course, you don't have to write the 1 whenever you have an exponent that equals 1. So, what about if we get x to the 15? Because I'm sure if you guys are looking at 14, 8, and 2, you notice that they all have something in common. All you have to do is half those guys, and that's how you get the answer to the square root of those variables. What about this one? We can't exactly half 15. And so we're going to have to borrow from the same idea that we used over here. We split the 50 up into two numbers. One is a perfect square. And so that's what I'm doing right here with the x to the 15. Now, x to the 14 and x to the 1 will multiply to give you x to the 15. And so will a bunch of other combinations of variables with exponents. Oh man, that's hard to see. Let me fix that. All right, that's better. But I won't use these bottom ones because if I do that, I'm just going to end up having to simplify again. And so this is all you have to do. You have to take one away from the number that you're given so that you get down to an even number. Now we have a perfect square right here. This guy is not a perfect square, so he's going to stay there. But this one is a perfect square. And as you guys saw earlier, the square root of 14 is 7. So now we can write this as 7, or x to the 7th times the square root of x. And that's how you simplify square roots. Now, if you had something like the square root of 50, x to the 15, you're just going to split it up like you did before. But think about it in two parts. Think about the number and then the variable. And sometimes there's more than one variable, so you're going to have even more to think about. So let's split apart the 50 first. So we have the square root of 25 and the square root of 2. And now for the variable, we have x to the 14th and x to the 1. Okay, this guy simplifies the 5, this guy simplifies x to the 7th, and the 2 and the x, they have to stay inside the square root. So we get 5x to the 7th on the outside, and on the inside we have 2x raised to the 1. And so that's how you would simplify them if they were together.